Hello all, welcome to Reinvent. My name is Shashidhar Vijay Kumar. I'm the principal CSM with AWS focusing on Amazon as a customer. For AWS, Amazon is like any other customer and we have an account team to help Amazon with their cloud journey. I have with me Suha Khan, Director of Security Engineering for Amazon Consumer Payments. And today you are in session AMZ 201 and we are going to be talking about how Amazon Consumer Payments built a secure, large-scale serverless payment system on AWS for internal use. Looking at agenda, we will be covering an introduction to consumer payments, what they do, what all product offerings they have, and how their previous payment infrastructure looked like. We will look at the problem statement, where did we start from, and what led to the new system. We will then look at Amazon Consumer Payments solution, how we built the secure system together. We will cover high-level key design decisions, and also we will talk about some key takeaways. Amazon Consumer Payments builds foundational systems and products that allow Amazon to accept payments for all goods, content, and services that people buy on Amazon around the world, delighting them with the best-in-class rewards, easy access to diverse payments methods, as well as simplicity to sell or buy on Amazon in their local currency. Some of the services and products include charges and disbursements for all Amazon customers across Amazon businesses, including Amazon.com, devices, and AWS portfolio. Gift cards, credit and lending products like Amazon Store Card, Amazon Prime Visa, Global Installments Lending, to name a few. Amazon Currency Converter provides Amazon customers with an option to pay in the local currency for select purchases. Shop with points. I would now like to welcome Suha Khan to take you through the rest of this presentation. Thank you.
Thank you very much, Shashi. I am the Director of Security Engineering for Amazon Consumer Payments, and I'm going to tell you about our journey in how we have built our payment service on AWS. Just before we start, a couple of things. Throughout my talk, please keep in mind two things. Firstly, while AWS and Amazon.com are both part of Amazon, when we work with AWS, we work as if we were an external customer of AWS. So just like all of you here, we look at the external documentation, we will engage customer support, we look at the API documentation, and we engage AWS as an external customer of AWS. Secondly, throughout my presentation, when I use the word customers, I am referring to internal businesses within Amazon, as our payment service is an internal one. So our customers are various businesses within Amazon, such as Alexa, Amazon stores, so on and so forth. So why are you here? I think you're here because you have sensitive data on AWS that you're handling and you want to protect it, just like us. For my talk, I'm focusing on payments data and how we have made a secure payments handling solution on AWS. Now, of course, here I'm not going to talk about the new payment system that Amazon is releasing. We are not doing anything like that. This is an internal service that we have built on AWS. I am also not here to give you a blueprint architecture that you can just take home and build. So today I am going to primarily have a security conversation with you around how to build secure services on AWS. Before I talk about our new service, I'm going to tell you a little bit about our previous solution, which was called the Payment Secure Zone, or the PSC. The PSC has served us very well for over 15 years. It is where we have stored and processed all of Amazon's charges and disbursement for all of Amazon businesses. And it is an on-premise infrastructure that is globally distributed in data centers, in dedicated cages within data centers that Amazon has. And it's essentially a network and security infrastructure, a tokenization service to store the data, a transmission service to transmit the payment transaction, and a payments database. This service has served us very well for about 15 years, and it's an on-prem, a large-scale service that we have built and operated over the years. Of course, this is a very high security bar, so when we want to have administrator access to this environment, the secure zone, we wanted to make sure that we have terminal rooms where employees come into physically and use the service instead of remotely accessing this environment. Because of this, over the years, Amazon rented apartments close to where these secure zones are located, so that on-call engineers can stay, and in case of a page that they need to respond to, they can quickly travel from the apartment to the nearby terminal room and access the system. Internally, we used to call this the CCBNB, credit card bed and breakfast. I'm going to tell you a little bit about the high-level architecture that we had, and it's very important because even though this is an on-prem architecture, the workflow and the pieces that you will see in this architecture is the same in the new architecture that we have taken in AWS. So here, when a customer of Amazon.com using the website to purchase something enters their credit card number and add it to their wallet, we will encrypt it at the browser and send it in through the Amazon infrastructure in an encrypted way into the payment secure zone, where a tokenization service will decrypt it and then send back a token to all of the internal services that need to reference this customer's credit card number. When the time comes to go ahead and charge the customer's credit card for a purchase that they have made, we will then, from within the secure zone, use the credit card number and send it over securely to an external payment service provider and process it. This design served us very well in terms of reducing attack surface, because all of Amazon services internally that have to charge customers only use the reference token, whereas within the secure zone we had an encrypted copy of the credit card number that is only decrypted when it's time to charge it. Now, what were some of the problems we ran into over the years with this on-prem infrastructure? I would say there were several factors that made us consider moving to AWS. I'm going to go through them now. Let's talk about security and compliance. As you know, the attack landscape is always evolving. And of course, maintaining the security bar is our #1 job, and it's mandatory, albeit the costs continue to go up. And the physical nature of the payment secure zone within a particular region made it challenging to adapt to compliance changes in the landscape. In particular, localization-related compliance rules where within a country, the government requires you to store the citizens of that country's data locally. For us, in our physical infrastructure, it meant that we would need to go ahead and purchase some buildings, build a secure zone, just like we have in other locations, and all the things that come with something like that. It became a pretty long effort to support a new region, which took us up to 12 to 18 months, and that will be going forward. Given localization is more and more common, that will be a blocking factor to the speed at which Amazon wants to expand. Operational excellence, generally speaking, server and network maintenance was increasingly complex and time-consuming. Of course, we had several different network devices from various vendors, and we needed to have specialized skills to manage those devices in our environment. Similarly, for our hardware security modules, where there are some certain sensitive operations, such as a new key injection have to take place, we will literally have to have multiple members of our team fly into a location along with their smart cards and go and inject the key, forming a physical quorum of trusted individuals. As discussed, physical access to the secure zone was required for administrator task, and we have, due to security reasons, we have never built remote access capabilities. So maintaining these physical terminal rooms, which had to be in close proximity to manage our hardware, was a challenge. And finally, when you think about scaling, our business is such that throughout the course of the year, there are a couple of peak periods around holidays in certain parts of the world where the demand is typically peaking. Which means you need to provision, and often we ended up over-provisioning for the entire year for a couple of peak periods of time with physical hardware, which was a waste of resources. Obviously, when you're able to only scale through additional physical equipment, there's always a risk that the demand will exceed what you can meet, and that continue to remain a risk that we had to carefully manage. Now let me talk to you about the new solution that we have built to replace the payment secure zone. This is called Lumos. It's an internal payment system that allows Amazon businesses to charge and disperse to customers for all of Amazon's transactions in a secure way using tokens, just like our previous architecture, but albeit on AWS exclusively. This is where we store a lot of our customer sensitive data, for instance, credit card numbers, bank account numbers, and any personal identifiable number from a customer that needs to be part of a payment flow. At a high level, when you think about Lumos, it is the same building blocks as the previous environment. As you see, the team that our overall workflow and our overall services and their responsibilities hasn't changed as we moved from on-prem to AWS is an important point, because fundamentally we didn't need to completely redesign our workflows and our services. When you think of Lumos at a high level, it's comprised of tokenization service, a transmission service, a security monitoring infrastructure, and automated compliance reporting. Lumos itself is compliant today with a number of regimes such as PCI. Now at a high level, speaking about the key services in Lumos, I'll start with tokenization. Tokenization is essentially our secure storage solution. It provides a tokenized API to essentially enable businesses to securely save a credit card number and return back a token that they can then locally save outside of Lumos, outside of the secure environment, for future operations whereby they will refer to this payment instrument in our case. We have a tokenized API for certain workflows such as compliance reporting. You can see how a certain number of records might need to be detokenized, which is essentially being given a token and returning a payment instrument. We have a delete API. There are lots of cases where data needs to be purged to meet certain regulations or just as a good measure, and this API exists as well. We enable ephemeral storage also, whereby a token is associated with a time to live. And once it expires, it is automatically deleted from Lumos. And for instance, during purchases, often there's information that the customer is asked to enter every single time that doesn't need to be stored, and we will use the time to live feature to manage that. Obviously, along all of this, a granular access control for all of our internal customers, such that data is isolated between our various customers and securely accessed only by the parties that have a need to access it, is also a part of Lumos tokenization. Now I'm going to talk to you a little bit about our Transmit API, which is the transmission service. Essentially, this is where the way we process charges and disbursement is through a set of global external payment solution providers. So when it's time to charge a particular credit card, we will go ahead and have a transmit call with a particular message or file. We support both online messages and files for a batch transmission scenario. We will then securely replace all of the tokens in these messages and files with the actual payment instruments within the secure environment, within Lumos, and then send it out securely to our partners globally through a variety of secure protocols that are supported. Now, when I look back at our journey, and I'm going to walk you through some of our key design decisions, it's important to realize that this was a pretty large undertaking for us to move from on-prem to AWS. We achieved it over 3 years with a 70-engineer team, and definitely the migration, due to the scale at which we are operating, and it has taken a lot longer than we had originally envisioned, just like any other large migration project. And at the beginning, as I keep thinking about what really pushed us over the line to make this jump, is while there were intrinsic benefits across the board from using AWS, a strong customer is in our case Amazon India, and a very strong business case, in our case a compliance regulation around data localization, was really the driving force, and that's what really pushed us over the line and get on this long journey. Now, as I'm going to talk through the rest of our journey and our design decisions, I want to just recap some of the requirements and how they essentially played out. First, as I discussed, security and compliance is our #1 job. So there are a lot of different requirements that are specific to those, and we'll walk through those. But throughout the rest of my talk, you'll see that about 60–70% of my talk will be around security and compliance, and that's just because really that's about how much of our overall effort was spent in these two buckets. Obviously, due to the problem statement I talked to you earlier, scaling and descaling on demand to meet peak traffic ask is an important requirement. Additionally, obviously, we need agility to launch localized payment storage and processing solutions with a low amount of effort. 12 to 18 months in our previous systems is just too high and not acceptable. So to be able to keep up with the fast-changing payment compliance regimes around the world, we needed the agility to be able to launch in a new region a lot faster. Beyond compliance, when you think about multi-region, you also have opportunity to get more resiliency, because you'll have to overscale a lot less if you have multiple regions available. And there are a lot of other benefits in being able to scale through multiple regions in a short period of time. Of course, cost efficiency was always an important aspect as well. While it's never the primary driving factor, at Amazon, typically savings in cost directly translate to better customer experience and lower prices. So it's something we really care about internally. When I talk about cost in this case, I'm talking about, of course, the cost of operating the environment from a billing perspective, but also the human costs associated with undifferentiated work that they have to do on an ongoing basis, like server maintenance, patching, provisioning new hosts, and so on and so forth. We were really aiming to significantly reduce the cost on that point as well, beyond dollars. Okay, now I'm going to talk through some of our key design decisions and how we made the trade-offs that we made as we built the new AWS-based payment system. Firstly, let's talk about a concept we call tenants at Amazon. It's an Amazonian concept, and it's essentially, you can view it as a principle or belief that help align teams and bring everyone into an agreement around critical questions that we face as we continue to build systems. These are a set of written guiding principles. We wrote 9 of them for Lumos. We reviewed it with our entire team. We aligned on them. And then we wrote them down and we checked them into our code repository and started appending them to all of our design documents throughout the last 3 years. These tenets are important because, and they are an integral part of our thought process. At the scale of Amazon, at the scale of our engineering teams, often key decisions are made throughout the organization. So it is not practical to have to resort to senior management or really senior engineers and SMEs for every single important design decision. Instead, tenets allow us to scale our decision making. Once all of the organization aligns on our core tenets, as they go and get into trade-off arguments and try to understand what's the best way to design something, they can always refer back to the tenets, which are our ground truths, and this often helps resolve some of our hotly debated topics. Now, along the same line, I'm going to start sharing some of the Lumos tenets we came up with and how we wrote them as they are in our code base. And I'll walk through some of our design decisions tying back to them. And I'll start with the first one, which is all about ensuring that we care about insider threats as much as we care about external threats. So that is a very important tenet. Often engineering teams might run into prioritization decisions where there's a discussion and the security person is saying, hey, you really need to fix this, and maybe the engineering team is pushing back and saying, oh, you need to be an internal employee to exploit that vulnerability. Well, we do not believe this to be the right way to approach it for Lumos, and we wrote it down, and whenever this argument is presented, we fall back to the tenet and quickly resolve the conflict. Additionally, once you make the jump to obsess over insider threats as much as external threats, you build your system such that internal employees do not have access that an external person wouldn't have. And any sensitive attacks are automated and require multi-person approval to perform instead of manual operations by a single administrative user. So what type of challenges, of course, designing a system like that poses? First, we need to now ensure that no single Lumos team member can lower the security bar of Lumos. It's a strong statement, and it requires us to think about our team and employees in a different way. I really like my coworkers, just to be sure, but I also like not having to trust them. As a result of this thinking, we made the decision that we will need to implement the separation of duties solution using the AWS primitives available to us via AWS organization and AWS IAM, such that we realize the requirement to have that no single team member can compromise Lumos or reduce the security bar for it. The way we did this in our example was to create 5 different teams of individuals, and I'm just going to briefly talk about each of them. One of them was our Lumos organization team. This team manages the AWS organization for Lumos and all of the SCP policies. They are the ones that are able to change these, and these SCP policies are then used to define permission guardrails for each of the teams within Lumos. For instance, this is the team that puts a policy that says IAM user creation and usage across all Lumos accounts is prohibited. And there is no other team that can override this in Lumos. Now, while these team members in the organization are able to set the policies, they do not have access to the systems themselves. And they are not able to push codes to Lumos. They are managing our SCP policies and overall organization. The second team we created is the IAM team, which essentially manages all of the AWS accounts for Lumos. These are the administrators of the AWS account, and their responsibility is to create roles for other teams. They can only create roles so long as the organization team's SCP policies are okay with it. And while they can create these roles with least privilege in mind, they cannot assume or use any of these roles. And they don't have access to any of the resources in Lumos. The third team we created is the foundation team, which manages Lumos's network infrastructure. These are our engineers who are really good at configuring and scaling networks and setting up connectivity with various global service providers. They own the network configuration of Lumos, both inside Lumos between our various VPCs, but also between Lumos and the exterior world, be it in our case, the Amazon internal businesses and their systems. While they can manage network configuration, none of these employees have ability to push code into Lumos or modify the application. They can only use the roles that are created for them by the IAM team that are conformant to the SCP policies that the organization team has set up. Then we have the Lumos application team, which is the team that's building the tokenization and the transmission services. And they are able to push code and make deployments to Lumos, and they build the API features of Lumos, but they do not have access to any of the accounts. They cannot create roles, they cannot modify the network infrastructure. They can only send data to places that the network infrastructure has permitted them to do. And they can only use AWS privileges that the IAM team and the organization team have accorded to their roles. And finally, we have a detections team in Lumos, which do not have any access to the Lumos accounts, but they have access to the logs from all of our accounts, and they build specific threat detections for our application. And then we, with these 5 teams, we were able to meet our requirement and say that to compromise Lumos will require compromising at least 2 of our 4 teams and the detections team. Now, the second part of our tenet around insider equals internal is the reality is Amazon is a very fast-paced engineering company, and developers really want and they prefer frictionless access to the systems that they build and operate in production. Typically, this is done via SSH, and of course, over time, the reality is that when an attacker would target a particular system, they would also use these administrative remote access systems to take control of your service. Our learning from over the years of internal testing is that remote access is the easiest point of entry for an attacker. So how did we respond to this challenge? Of course, we can build a lot of systems around locking down remote access, making it only happen through a secure host that you're really spending a lot of time securing. Or you can come up with an idea where, hey, you have remote access, but it's not on by default. The reality is, over time, as systems mature and operational needs come and urgently come, you will likely end up in a place where, because the possibility of remote access exists, it will just be enabled and it will be there forever. Knowing this, what we have instead chosen is to build our entire workloads on systems that do not provide remote access by design. It's simply not something that's possible. So no matter how much frictionless access is needed for our engineering teams, it will simply not be a possibility. Therefore, we made a choice to use AWS Fargate and DynamoDB, and we made the choice to have 100% of our infrastructure as code. So while we went with Fargate, when we looked at what it means for us and looked deeper into how AWS implements this, we chose the Nitro system and required that all of our Fargate tasks to run on Nitro. Nitro is one of the 2 hypervisors that is possible for an AWS customer to launch their tasks on. And we found it to be an extremely well-designed, robust system that uses hardware-backed security. And even the AWS teams themselves do not get remote access to the host on top of which our Fargate tasks will run. We were very happy with that as the foundation of our infrastructure. We went with 100% infrastructure as code because now we don't have remote access. We want to make sure that all of the changes that happen in our environment, infrastructure, application, they all go through code deployment pipelines. This is an extremely important security property. So we went with AWS CloudFormation. We heavily use Cloud Development Kit, and this really helped us remove operator access completely, not needing it, and go through and inspect every single change that is happening, whether to our infrastructure or to our application. And we use Lambda for automating our sensitive tasks, such as annual key rotations and things of that nature. Now I'm going to talk you through another tenet that we have. And this is all about building automated security controls instead of manual security controls. And also ensuring that at any point in time, we know that they are working. This is a very important property. Over time, whatever security control that you might be building might silently fail, or they might fail in a way where you had to respond to some operational incident and make a lot of changes, maybe turn off a bunch of noisy alarms that it will generate, and you turn off a bunch of security controls and you have never re-enabled them. We need to know if something like that ever happens in Lumos over the next 10-15 years. So the way we went about that is we needed to not build a security control for every threat that we identified in our threat model, but we also needed to make sure that there's an automated test in production, what we call a canary, a security canary, for each of the controls that we have implemented. And these security canaries and the security controls come and become in the hundreds just because of the extent to which we have gone in our threat model and then security controls. And that becomes an important task for us to think about, because it's a large number. We need to build a lot of controls and a lot of security canaries, all in production, and we need to be able to monitor their effectiveness in real time. Example of a control, for instance, let's say is that there's a you can have a network egress rule such that egress from a particular task over the network can only reach certain specified destinations. So this is your control. You have a network rule somewhere, a VPC policy, whatever. The security canary associated with that then would be a piece of code that runs within that same environment in production and tries to egress data out to an unintended destination in real time, all of the time. And if it ever succeeds, it will create a notification and a high severity security event, and we will act on it as if the control has been ineffective. So what did this lead us to? Because of the sheer scale and the number of the controls that we need to build and the size of our teams, we needed to have an underlying service that essentially provides an ability to build controls and deploy them and have them report and monitor their effectiveness as a service. So within Lumos, we built a real-time monitoring system for all of our security canaries. We leverage Security Hub for the presentation layer. And we essentially utilize all of the events from all of our AWS services in real time through a Kinesis stream, as well as our application. We analyze them. And when certain conditions occur, we will create alerts. And those alerts are integrated with our Amazon internal ticket management system for notification and response. The cool thing about this is that this abstraction and providing security controls as a service enabled our Lumos teams to be able to move a lot faster in security control development, while all the plumbing and notification, data aggregation, and all of those things for all of their controls is taken care of by the system. They only can focus on the logic of their particular security test and security canary and or detective control that they want to implement. This typically is in the form of a Lambda. So this service enabled us to build all of our controls and security canaries in production and meet our security requirements from that perspective in real time. So I think for us, it was super important to have real-time monitoring of all of our controls in production via security canaries, even though it was a costly investment for us to make. Now we have talked a lot about the security controls that we have built. Obviously, the vast majority of these are application security controls, things that correlate the encryption calls with customer calls and things of that nature. How did we then think about the AWS provided controls, right? And we already established that we do not trust that our controls are doing their job unless we have a security canary. So how do we think about AWS? This was a hotly debated topic within our team. Where we landed finally is that we leverage AWS managed infrastructure as much as possible for all of our security controls. We follow AWS best practices, the external documentation to use AWS provided security controls whenever possible. Let's say we found a security control that existing AWS services is not providing. Our instinct is not to immediately go ahead and build one ourselves, but is to require through our customer support and account executive to AWS, whatever AWS service is in question, and have them build it as part of the feature so that all of the AWS customers can benefit from it. There were multiple examples throughout our journey where this, I believe over 20 times, important features that we needed were delivered by AWS upon this type of conversation. Instead, if we had built it just for our application, the rest of the world probably would not have benefited from it as quickly. A few examples of that I remember definitely is Route 53 DNS logs is something that we really cared about. We had a bunch of security controls that look for DNS-related anomalies in the queries originating from our services. So while originally we had planned to have a custom resolver such that all of the logs for all of the DNS requests within the Lumos environment are logged, and we can then build anomaly detection on top of that. We worked with the Route 53 team to have the Route 53 DNS resolver logs available to customers, which really simplified our design in that regard and removed another important point of failure. As DNS is such a core thing to do, it's better for AWS to do it if you can really avoid it. Another example of that was Macy's. We are using Macy for looking for sensitive data that might end up in places it's not supposed to within our environment. And there were cases where just because of the different types of formats and messages that we deal with at our scale, there were some gaps in how well the detections were measuring up to the requirements that we have. So we have worked with them to improve their detection capabilities. And finally, when we first wanted to launch in the India region, our Fargate tests were not able to run on Nitro. They didn't have the Nitro clusters there yet, and we really made this an important blocker for us and early on engaged AWS to make that happen, such that our Fargate tests in India run on Nitro. Now, this is how we approach the AWS, but it's very important to say that while we trusted AWS controls, right, like when Route 53 told me that I will get all of the DNS logs, I trust Route 53 to give me all of the DNS logs, and I don't try to test it. In our team, we still did not trust our usage of these AWS services and controls. For instance, we use GuardDuty. We know that GuardDuty is doing its job, but we do not trust our configuration of GuardDuty. Because of that, we have, for instance, a security canary that ensures that all of our accounts have GuardDuty enabled with the right tools at all times. So that's kind of how we approach the AWS provided security controls. We trust them. We know that they do what they are doing. When they don't, we go ask AWS to make it so, and we work with them. And when we use them, we do not trust that our configuration of them is always going to be correct, so we build automated security canaries to ensure that's always the case. Now I'm going to talk a little bit about another Lumos tenet, which is principle of least privilege. This is pretty much a very well-known security principle. You provide access to resources necessary for a system to perform their job and no more. The reality is, if you do not do that, and if you do not stand by this tenet, over time, all of your systems and all of your users are going to have all of the permissions, and you will not be able to stop them. So our approach here was to ensure that we have a centralized system, in our case the IAM team, that manages all of the permissions. And this is the counterforce against the natural tendency of permissions to creep over time. So when you think of what it meant for us, well, several things. First, okay, we have centralized all the policies and permissions. These span tons of different things, right? This is basically about which APIs each of the roles can access, which VPCs can talk to which VPCs and how. This led to a very large number of identity policies, resource policies, service control policies, VPC endpoint policies, and security groups, access control lists. It really turned out to be tens of thousands of lines of these policies. And while they are managed by a dedicated team, obviously, and each change to them goes through a deployment pipeline, it's just too large a number to have tens of thousands of lines of these policies that for any human to really wrap their head around. And we definitely went and implemented scanners that look for severe misconfiguration errors that are just that might be missed in some review or another. But above and beyond that, we really needed to go, and at that point, I reached out to some of my friends at Amazon who do logical reasoning and automated reasoning, and work with them to incubate a small automated reasoning team within our Lumos team. And that team, essentially, via mathematical analysis, using the engines behind these three services that you see on the right-hand side, the VPC Reachability Analyzer, IAM Access Analyzer, which is awesome, by the way, and Amazon Inspector engine. Using the engines behind this, reasoning about all of our tens of thousands of policies to ensure that we have a full map of data and where it can flow from for all of our Lumos resources and every part of our infrastructure, and ensure that data always remains to each change to Lumos and can never go to locations within Lumos where it's not supposed to be. So even within Lumos, we came up with this concept of a red zone. This is where the data is, critical data is. And with each change, with each check-in, we have automated reasoning running and making sure that red data remains in red zone and cannot go to a non-red zone without passing through a red to non-red connection. So we have logically separated our environment, our zone, into three pieces, three different areas, and mathematically proven with each check-in that data remains in the zones that it's supposed to. Our next tenet is around thinking in defenses and making sure that we do not, the realization is that any single layer will eventually fail over time. And we have built for every threat that we identified a preventative and a detective control. And we have built our defenses both at the perimeter but also inside our perimeter, such that to be able to successfully pull off an end-to-end attack should require an attacker to chain multiple vulnerabilities and for us to have multiple controls fail. What does it mean? Essentially, obviously, we have the boundaries of Lumos. and we protect data there, and we protect the connections there. So we use API gateway, we use SIGWI for authentication for Lumos, we use API gateway for throttling, we use Shield Advanced for DDoS protection and other things. We use WAF to give us control about how our traffic is supposed to move. But we don't stop there. Within Lumos, using the identity and access layers, I am an organization, we continue to build both network and identity controls and segregate the various roles that we have and the various network locations that we have within our network. And we did that primarily by using the AWS organization. For instance, when you think about layers of defenses in this context, let's say a task like a tokenization task is compromised. Well, tokenization is not able to egress data out of Lumos. And tokenization VPC can only send data to a certain small number of other VPCs within Lumos, none of which are at the boundary. And while an attacker might fall there to egress data, they will not be able to do it via the network, and they can start writing it to some logs, but we monitor all of our logs and we use detections on our logs to ensure that the data is there. Essentially, this approach of not just building a walled garden, where inside the garden it's really nice and plentiful for all attackers to move about freely. We have made no difference between internal and external boundaries, and we have invested in securing both through a combination of network but also identity and access layer controls. The next tenet is simply a realization is that security is never done. Attacks only get better. Adversaries are creative and persistent. We must come up with ongoing mechanisms for security assurance. In this case, all these building blocks should be very familiar to any security team, but we do them on an ongoing basis. We do not consider threat modeling as a one-time task, and just before launching a service, you do your threat model. It looks really good. Everything is super secure, and then you launch it, and 4 years later, that threat model has nothing to do with the service you have in deployment. So we have continuous threat model reviews on an ongoing basis within our team, such that we update the controls and the risks that we have based on the changes in our design and features. We have really come up with a way to do separation of duties, but we still want to make sure that the code that ends up in production is sound from each team's perspective. So we have embedded security engineers dedicated to each of our 5 teams that review every single check-in that happens to Lumos and has to sign off just like a software engineer has to sign off from a functionality perspective. We have established a peer review mechanism with AWS. Through our account management team, we regularly review our threat model and overall security posture with them. Obviously, we do pen tests on an ongoing basis for any time we launch a new service. We also leverage drift detection to identify specific areas of high churn and do ongoing pen tests on that as well. We incorporate insights and telemetry from emerging attacks, and we will go ahead and self-assess ourselves and make sure that our system, as attackers and attacker techniques continue to change and improve, our system's defenses are also measuring up. And finally, something that we have done very early on is to build our own offensive security team or red team. This team's entire job is to continuously target the Lumos application and leveraging both internal and external attack vectors, including social engineering. Just adversary emulation is the approach we are taking in an end-to-end way. Ensure that from a holistic perspective, our security security features and dependencies continue to hold up against determined attackers. Another tenet that we have is essentially Lumos. One of the things about tokenization is it's data custodian service. And when you think about Lumos within Amazon, it is the only authorized system to store payments data for our customers. So by just having this policy at the enterprise level, as all of Amazon businesses continue to build and grow, you continue to keep the consistent security bar for the payments data, which essentially equates to the security bar of Lumos search service. We talked quite a bit about security. Obviously, it was a major part of our effort, but I also want to briefly touch upon some of the requirements in the other aspects of Lumos. One of them is around scaling our new region. As I said, Lumos is 100% infrastructure as code. It's 100% hosted by AWS. We do not have to deploy our infrastructure for peak utilization. This offers us cost benefits. We have, just like many of you might have, infrequent but highly intensive workflows, such as data crawlers and things like that run maybe once a year. We also don't have to specifically think about that because just by using our Fargate, scaling happens only on demand and is needed, and it's really awesome to live in that world. Launching new regions, well, previously, as I mentioned, it will take 12 to 18 months to launch a new region. Here, it takes us about 2 months to do so because we use infrastructure as code for our deployments, and we have done that a few times, which is really important gain. When I think about cost, we are seeing about a 30% reduction in our capex costs compared to our physical infrastructure. Above and beyond the dollar savings, our humans are spending a fraction of their time now compared to before on maintenance tasks, such as patching operating systems or provisioning hosts. So, which is really great for us. They can focus on much more creative activities that they really prefer. Finally, on the resiliency, wherever supported, we use 3+ AZs for our deployment, and that has given us the 4 nines that we seek to maintain from our previous environment. So what does all of this mean to you, really? Here I want to briefly summarize some of the things. First, internal equals external as far as threats go. Use separation of duties to avoid single points of failure in your team, but do not deprioritize controls just because it requires an insider to bypass them or take advantage of your service. Remote access is the easiest point of entry into your system. If you have it, you might as well get rid of it. Of course, do it safely. A good point you can pass from perhaps from having a lot of remote access to no remote access is starting to introduce multi-person approval and a break glass procedure, which we have also done earlier on in Lumos, whereby multiple humans from multiple teams have to approve an enablement of a spatial role that's disabled by default that can then be assumed under a break glass procedure to perform a sensitive task, and then the role is disabled again. So that could be a good way for you to start really introducing some friction into remote access. And this, if you do it this way, consider each access to your production environment as a defect, and try to make sure that the same access doesn't happen the next time around, either through generating more application logs or automating whatever sensitive task was needed to be performed. I think you can over time reduce your remote access, and it will be a highly leveraged investment for security. And when I talk about remote access, I'm talking, of course, about SSH, but also AWS identity layer. So AWS console access and SSH, I do not differentiate between the two. You need to really reduce both of them and get rid of it if you can. The third thing I want to tell you about is over time, things will fail. And I'm talking about security controls, so you care about these things. You should always know whether your controls are working. And you should do that in an automated way in production. When you're building your system and security infrastructure, build your defenses in layers. Do not just rely on perimeter controls. Do not deprioritize controls within your perimeter. At any point, I can guarantee you that any of the controls you have will fail. You can raise the cost of a successful attack by building additive layers of preventive and detective controls at the boundary and within your environment, at the network layer and at the higher layer like AWS identity and access layers to raise the cost. We made the choice to use serverless to build our highly complex, very high scale, Amazon scale payments application. And we are pretty happy with it. In fact, when we started writing down our Lumos tenets around remote access, around least privilege, around layers of defenses, inevitably we found that serverless is the way to go across compute, database, and so on. In fact, the fact that it's not possible to SSH into our instances makes me sleep very well at night. And turns out our developers did not really need this lever. When they can live in a more constrained world, they try and adapt to it. Get feedback about your security posture. Do not believe the results of a compliance finding or a pen test finding. I think investing in our own internal offensive security or red team, making the hypothetical real as far as attacks go, and testing our application like external adversaries would really enabled us to have a much well-rounded view of where our security posture stands. Partner with AWS. Here, as I said in the beginning of my talk, we treated AWS like an external customer would. That's just how Amazon.com functions. And we from a very early day, we engaged AWS through the mechanisms that they have, provided feedback, escalated with the various service owners using our account executives, and really had very good outcomes in terms of being able to have AWS meet our demands, especially in the domain of security controls, as I mentioned before. So it's very important for you to have a very deliberate engagement plan with AWS from the earlier days of your project, especially at a large scale, highly sensitive workload like ours. Finally, I truly believe after having owned and operated the on-prem environment for a number of years, and then now the cloud-based payment infrastructure that we have built for Amazon, I am definitely of the opinion that security is better on the cloud. It doesn't mean that you won't do security. Obviously, this whole talk was about all the security work that my team had to do. However, the type of activities that our engineers spend their time on is a lot different. While previously most of our efforts were undifferentiated ones such as patching, maintenance of firewall rules and things of that nature, here in a serverless world with the decisions that we have made, we are actually solving problems that I think are a lot more interesting for both security engineers, and it really results in a much more energized team and a higher security bar overall. So AWS is very good at this infrastructure stuff. Go 100% infrastructure as code and serverless. Audit every one of your change at the software layer. Let AWS take care of maintenance and security hygiene, which is just something they are super good at. Now here are some of the resources from AWS that I might have touched about. If you're also curious about tenants and Amazon uses tenants, I also have a link here for you. And with that, thank you very much for spending time with me and with Shashi. If you'd like to reach out to me, you can work with your AWS account manager to do so. I work at Amazon. Yeah, thank you for listening to our talk. Hopefully it was insightful for you.